A variable is going to be something in my code that can hold a value. Why might I want to hold a value? I might want to, on my microcontroller, I might want to plug an LED or a button in, and I will need to be able to tell it which place that button's in. It's numbered. It has numbered spots on where I can plug my hardware in, and so I might need to be able to save a value telling it where is this light or where is this button. I might also want to plug in some type of sensor, and that sensor might come back with a value telling me about how bright something is or how loud something is. And again, I want to be able to save that so I can reference that later. Maybe I want to save a time, and I want it to be able to tell me how long it's been since a certain event, or I want it to wait a certain amount of time. So I want to put in some variables so that I can be able to have these values saved. So think of computers and microcontrollers as very, very, very good at following instructions, but very, 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 very bad at remembering anything unless you specifically tell it to. It will actually not remember anything line to line unless you tell it to remember it, and then it won't even recall it later unless you specifically tell it to recall what was saved. So the first thing we have to do when we're talking about variables is we need to be able to figure out, if I'm going to save some type of value, what is the size that it's going to save. It's not smart enough to know, because this is a certain type of number, I need to give it this much space to save. So what I'm going to do is, myself as the designer, and again, this is a design class, I need to figure out, and I need to tell it how big of a number or what type of number I'm going to be using. And those things that we're going to be telling it, the size that it's going to be, is called a data type. It's telling us what type of data we're going to be saving. So I'm going to go over some of them. There's going to be more. This is just going to be a basic overview. And one of the very most common ones that we're going to be using, I'm going to close that. The most common one that we'll be using, or at least one of the common ones that we'll be using, is called a byte. And when I type in these data types, you'll see that they turn a specific color. In this Arduino software, they turn kind of this bluish color. If I'm typing in some other software, it'll change color, but it might change something slightly different. Such as, let me see if I have this open here. This one's also, looks like blue. Yeah, kind of a bluish color here as well, but I've seen it turn other colors as well, so just be aware of that. But the fact that it changes color tells me something very good. It tells me that Arduino recognizes it as a keyword or something that it knows, which means that I did something right. If I accidentally misspell byte and spell it B-I-T-E, you'll see that it stays black. It doesn't change. It doesn't recognize it as anything. So byte. Now what is a byte? A byte, we can go over this in class, or maybe we can talk about it on another video. A byte is 8 bits of information. Now a bit is a single 1 or a 0. And if I line up 8 of those together, then I have a binary number that has 8 digits in it, and that binary number with 8 digits is a byte. It can hold a value from 0 to 255. So if I know, me as the designer, me as the creator of this sketch, if I know whatever value I'm going to store is not going to be negative, and it is never going to be above 255, and it is never going to have a decimal point, then I would want to choose byte as the type of data that it can hold. I know that's kind of confusing. There's a lot of stuff there, but you have to think kind of in advance, what are my possible values that can go into here? So let's say that I wanted to turn on an LED, and on the Arduino, the best places to plug in an LED, there are probably some other options, other ways I could do it, but to start out, we'll keep it simple. I can plug it in onto my digital side of my board. That's going to be the way that I have mine oriented. The digital side is on the right. I can plug it in into pins 2 through 13. Well, those are not 0. They do not go above 255, and there are no decimals. So I'm going to give it a data type as a byte. I have to have a space here, and then I have to give it a name. I have to tell it, okay, so later on when we do save a value into this, how are we going to recognize it? How are we going to know what you're talking about? And so I have to give it a name. I'm going to give it a name, just like you in math, when we have variables, we give it a name, such as x, y, or z. I'm going to do the same thing here, but normally I like to give mine longer names that are a little bit more descriptive. They don't have to be single letters here. So again, if I'm going to be putting an LED in here, I might call my variable LED. And so what this is doing is it's telling the microcontroller to save a byte worth of storage in memory, and we're going to call that space LED. Now, if I wanted to right now, anytime that I've written a line of code and I've given it one step to do, what I need to do is I need to say, go and do this, and now you're done with this step and you can move on. Before it can move on, when it does one thing, what I have to do is I put a semicolon. And what that semicolon does, it's the end of the command. It says, do this, stop, you're done with that task, now you can move on to another task. It's one step of something that it can do. Now in this case, what it's done is it has made a space called LED that has this type of data in it, or the ability to put that type of data in it, but currently there isn't any data in it at all. And this is a perfectly fine thing to do, but I can also store data in it right now. And so if I'm going to do that, I'm going to put an equal sign after this. And this equal sign is not like an equal sign that you would have in math. It does not mean equal to. A single equal sign in Arduino is an assignment operator. What it means is I'm going to put a value over here. Let's say I plug I want my LED plugged into 13. Anything to the right is going to get assigned to the thing to the left. So what it's going to do is it's going to take the number 13 and it's going to assign that value of 13 to LED. I can't put it the other way around. I can't say 13 on this side, LED on this side. That would try to take the word LED and shove it into the number 13. That doesn't make sense, but what I can do is I can take the number 13 and I can put it into this variable called LED. So there's one other thing that I want to discuss on this video. We'll get into more depth on variables on another one. And that would be, because this is a variable, it can be changed. And sometimes that's a good thing, but if I have an LED plugged into pin 13, I'm not planning on unplugging it and putting it somewhere else. I don't want that value to change. We're still going to call it a variable for lack of a better word for now. But what I want to do is I want to make it a constant. Once I save 13 into here, I don't want it to change ever again. So what I can do is in front of the word byte, I'm going to tell it to be a constant. And I do that by writing C-O-N-S-T, const, in front of all this. What that's going to do is it's going to take the number 13, assign it to a byte worth of storage called LED, and then it's going to lock it. It's going to lock it so that I can't change the value of 13 later. LED has the value of 13, and it will the entire time that this sketch runs. That's all that it can do.